Hi guys, today we'll discuss this Cayley contest problem that combines both probability and geometry. This is question number 23 from year 2014, and it reads that three friends are in the park. Bob and Clarise are standing at the same spot, and Abe is standing 10 meters away. Let's just call them A, B, C, right? B chooses a random direction and walks in this direction until he is 10 meters from C. What is the probability that B is closer to A than C is to A? So let's start out by understanding what the question is really asking, and we do this by drawing it out. So we have two groups of friends, right? A is alone by himself, and B, C, they are together. See it right here, right? And I know that the distance between the two is 10 meters. Okay, cool. Now the second step says that B will choose any direction, right? Any of the directions to walk for 10 meters. So how do we characterize or model the position of B after walking? Well, first of all, B is going to leave the spot, right? So C stays. So B will actually, his position could be on any position on this circle, which is centered at C, right? And has a radius of 10, right? Because we know that in a circle, right, the distance from the center to any point on the arc is going to be the same, right? Which in this case is going to be 10 meters, right? So this is B's position after walking. Could be anywhere on this graph, on this arc, with equal probability. Okay, so the question is asking, what's the probability that B will be closer to A than C is to A? And we know that the distance between C and A is always fixed to be 10 meters, right? So in other words, we can paraphrase this question as, what is the probability that B will be within 10 meters of A, right? So how do we characterize or model all the positions that are 10 meters away from A? Well, using a similar idea, right? Use A as a center. I'm going to draw a circle centered at A, right? And it's going to have a radius of 10. So anywhere on this arc, the blue arc, is going to be exactly 10 meters away from A, right? Anywhere within this arc, right? So say if B were right here, then B will be closer to A than C is to A, because B will be within 10 meters of A. Okay, so basically we'll paraphrase the question saying, what's the probability that B will be within this region? Okay, so we look at the boundaries, right? By boundaries, I mean where the blue and the green lines cross, right? So look at this point. This is a very interesting point because on this point, the distance between this to A will be 10 meters because it is on the blue arc. The distance from this point to C will also be 10 meters because it's on the green arc, right? And similarly, we can say the same analysis about this point below, right? So it's same distance, right? It's 10. From here is also 10, right? Cool. So as long B, he's within this region, then he'll be closer to A. So what is probability that he'll be falling here? So let's look at this triangle, right, on the top. So we know that this is an equilateral triangle. Okay, do you know what's the angle here? Since there's only one way to construct an equilateral triangle, this has to be 60 degrees, right? Because remember, the sum of all three angles in a triangle must be 180. And the same thing can be said about this angle. It must also be 60 degrees, right? In other words, as long B travels within this 120 degrees, right, within this kind of a fan shape, right, then he'll be closer to A than C is to A. So what is the probability that B will be within these 120 degrees, right, out of the whole total 360 degrees, right? Assuming it's a uniform distribution. So we know that the solution, therefore, must be 120 out of 360, right? In other words, it is equal to 1/3. That's your probability.